In the second part of section 6.3, we're going to continue to prove trig identities, but these ones get a little bit more challenging. So sometimes we need to be aware of our double angle identities to prove an identity. So you notice in this particular question I have a double angle identity down here and a double angle identity here. So again, it would be useful to have your double angle identity sheet out. So again, remember we can't cross the equal sign. And on the left-hand side, I have 1 over cotan, which is our reciprocal identity. Again, 1 over cotan, if I move cotan up to the numerator, it becomes its reciprocal, which is tan. And we know that tangent is really sine over cos. So that's what the left-hand side equals. Now, when we take a look at our right-hand side, one of these strategies is you want to get rid of your double angle identities. Well, the bottom is pretty easy because sine 2x only has one identity. Now, if we take a look at the top, I have cos 2x, and cos 2x has 3 identities that you could use. I believe the 3 of them are cos squared x minus sine squared x, 2 cos squared x minus 1, and 1 minus 2 sine squared x. So we want to make a substitution using one of these. Now, because I have a leading 1 here and there's no 1 over here, it would make sense to pick something that when I distribute this negative sign to whatever substitution I make, I end up with a negative 1. So it seems to make sense then that I should use 1 minus 2 sine squared x in place of cos 2x. So if I go 1 minus 2 sine squared x over 2 sine x cos x. So now when I distribute, I get 1 minus 1 plus 2 sine squared x over 2 sine x cos x. And now the 1's are going to cancel. And now this 2 can cancel out with that 2. And one of the signs up there will cancel with one of the signs there. And you are going to be left with sine x over cos x. And that's what you wanted to show. So again, QED. So the whole proof unfolds quite nicely if you get rid of your double angle identities. Now you could have used the other identities. It would have taken more work to simplify. So sometimes using some deductive reasoning off the start with our initial substitution helps us prove the identity the easiest. Okay, in this particular case, again, I have my right side, which is sine x over cos x. And again, sine 2x is pretty straightforward. It is 2 sine x cos x all over. Now I have a plus 1 at the end, so it makes sense when I substitute for cos 2x, I should put something in that's going to result in a minus 1. So in this case, it makes sense in place of cos 2x to use the 2 cos squared x minus 1, so that's going in place of that, and you still have your plus 1 at the end. So now this reduces to 2 sine x cos x over 2 cos squared x. So now the 2's cancel. This cos cancels out one of those. And you're left with sine x over cos x. And again, QED. Showing the left side equals the right side. Okay, another strategy that sometimes comes into play is sometimes we have to multiply by a conjugate. And by multiplying by the conjugate, we will usually introduce a Pythagorean identity. And if you notice, again, we can't cross the equal sign. I have 1 minus cos x on this side, and I have a 1 plus cos x on this side. Those are conjugates. There's nothing I can do as far as double angle identities or anything like that. So it makes sense to multiply either 1 minus cos x by its conjugate or 1 plus cos x by its conjugate. So I'm going to deal with the right-hand side. I'm going to multiply by 1 minus cos x over 1 minus cos x, which is really a form of 1, but it's also the conjugate of 1 plus cos x. Now, here's the key. Only FOIL out the conjugates. Leave the other two just as factors. So I have sine x times 1 minus cos x all over. If I FOIL out the conjugates, I get 1 minus cos squared x. Now, if we look to what we want to try to prove, I want to try to get a 1 minus cos x on the top, and I already have that here. So now, if we use our Pythagorean identity, I can change the denominator, because 1 minus cos squared x is really sine squared x. And now this sine will cancel out with one of those, and you are left with 1 minus cos x over sine x. And that's what I wanted to show, that those two equal. So again, you could have multiplied this side by 1 plus cos over 1 plus cos, and again multiplied out the conjugates, and the same thing would have unfolded, but I just chose to do the right-hand side this time. Okay, in this particular question, very similar to the previous one, I'm going to try to get 1 over 1 plus sine x on the right-hand side. So the first thing I'm going to do, if you notice, is I have a common term of secant x here. And now notice I have this and this, which are conjugates, so I'm going to multiply by 1 plus sine x over 1 plus sine x. And before I multiply those out, I'm going to move this secant down to the bottom. So if I move this down to the bottom, it becomes another cos, so this really becomes cos squared. So now when I multiply out the tops, I'm going to get 1 minus sine squared x over cos squared x times 1 plus sine x, and 1 minus sine squared x, according to our Pythagorean identities, is cos squared x. And I think you can see how this is now going to unfold, because now the cos squareds cancel out, and I'm left with 1 over 1 plus sine x, and that is what I wanted to show, so quite easily done. Okay, in this next example, this one's a little bit tricky because it involves some double angle identities and it involves some factoring. So let's first of all deal with the left-hand side. Cotangent x is really cos x over sine x, and cosecant x is 1 over sine x. And if I combine those, because I already have a common denominator, I'm going to get cos x minus 1 over sine x. So that's what the left-hand side equals. So in place of my double angle identities here, I have double angle identities to deal with. Well, notice all I have is cos x's in the numerator here. So when I use my substitution for my double angle identity, I'm going to leave everything in terms of cos. So cos 2x becomes 2 cos squared x minus 1. And I'm still subtracting the cos x. And in the bottom, sine 2x is 2 sine x cos x. And I still have that plus sine x. So now I'm going to rearrange my numerator. And I'm going to factor a sine x out of the bottom to get that. Now, if you notice, this is a quadratic, and I'm going to factor that quadratic because it factors quite nicely into 2 cos x plus 1 times cos x minus 1 all over sine x and 2 cos x plus 1. And now the 2 cos x plus 1s will cancel, and we are left with cos x minus 1 all over sine x. And QED, I've shown that the left-hand side equals the right-hand side. All right, you might want to take a second to pause the video and give this one a try. Okay, I hope you had a chance to try this one, and let's try and attack it. First of all, if we look, we have one double angle identity, which is right here. So let's get rid of that, and the only substitution I have for sine 2x is 2 sine x cos x. Subtract cos x. And this is a difference of squares on the bottom, so that will factor into 2 sine x minus 1 and 2 sine x plus 1. Now I can factor a cos x out of the numerator and get 2 sine x minus 1. And I have 2 sine x minus 1 times 2 sine x plus 1. And now the 2 sine x minus 1's cancel. And my left-hand side is 2 sine x plus 1 in the denominator. So there's my left-hand side expression of cos x over 2 sine x plus 1. Now, if we take a look at the right-hand side in the numerator, I could factor out a cosine x, and I'll be left with sine squared x plus cosine squared x all over 2 sine x plus 1. And hopefully you're realizing that this is our trig identity. That sine squared x plus cos squared x equals 1, so that drops off. I'm left with cos x over 2 sine x plus 1, and QED, we've proven that the left-hand side equals the right-hand side. So again, we've covered a number of strategies in this second half of proving identities, getting rid of the double angle identities, multiplying by the conjugate. We had some factoring here. We had some factoring of a quadratic here. So you just have to be aware of the different situations as you attack these problems. Okay, there is your assignment for the second half of section 6.3. The answers are posted on the webpage, and if you have any questions, feel free to send me an email.